Hey everyone, welcome back to Easy Electra, your go-to hub for electrical, PLC, SCADA, and automation content. I'm super excited about today's video because I'm going to walk you through a complete SCADA-based industrial automation project that I've personally built and tested from the ground up. If you're someone learning industrial automation or working on projects with Factory.io, FactoryTalk View, or Studio 5000, then trust me, you don't want to miss this. Grab a cup of coffee or chai, sit back, and let's explore this project together. From screen design to PLC logic to full-on simulation. This is going to be a deep dive, and by the end, you'll not only understand the process, but you'll also get inspired to build your own system. Let's begin with the overall concept. The idea is to simulate a real-world automated bottle filling and capping plant using 2 conveyors, a water tank, sensors, actuators, and a full-fledged SCADA interface. I've used FactoryTalk View to design all the HMI screens, Studio 5000 for the ladder logic and automation programming, and Factory.io for the visual simulation environment. Since Factory.io doesn't include actual bottles, I've creatively used small boxes to replicate bottles, and trust me, it works just as well. We'll first take a look at the main screen of the SCADA. It's a neat layout with intuitive navigation. The header shows system status, active alarms, and a blinking indicator to show whether the process is running. I've used a custom color palette, avoiding blue since it's already used for the water tank, to make it visually clear and pleasing. There are start, stop, and emergency stop buttons. When you press the emergency stop, the system latches off and a blinking reset button appears. This can only be used once the emergency is cleared, adding a realistic safety interlock. Next is the conveyor screen. I've got 2 conveyors in action, Conveyor 1 for filling and Conveyor 2 for capping. Sensors are placed at key points to detect bottle presence. Once a bottle is detected on Conveyor 1, the system halts, triggers a filling valve, and resumes after a set time. Conveyor 2 then takes over for the capping process. This is all controlled through over 60 rungs of logic in Studio 5000. I've used latching, timers, counters, and interlocks to make sure the system behaves just like it would in a real industrial. Now, let's switch over to Studio 5000 and talk about the programming. This is the brain of the entire operation. The logic includes everything: sensor detection, conveyor movement, filling logic, capping logic, emergency handling, and even a bottle counter that keeps track of how many units have been processed. I've used a CTU counter for this, and it's linked to a sensor at the end of Conveyor 2. The program is modular, organized into logical sections to make troubleshooting easy. Speaking of troubleshooting, I've built a solid alarm handling system in FactoryTalk View. The alarm screen is configured with a bootplace overlay display type, so it can pop up without switching the entire screen. Each alarm has a clear message, like gun tank level low or auto emergency stop activated. Severity levels are defined: low for warnings like tank level, medium for process alerts, and high for safety critical events like an emergency stop. The minimum duration is set to 0 so the alarm appears as soon as the condition is true. Moving to the trend screen, this shows the water level in the tank over time. It's a useful diagnostic tool to monitor system behavior. The tank level is controlled by analog values, and I've configured alarms for both high and low levels. On the HMI, if the level drops too low, you get a blinking warning and a sound, depending on configuration. Now, let's jump into Factory.io and show the simulation live. You'll see small boxes moving along the conveyor, being filled and capped just like bottles in a real plant. The moment a box is detected, the conveyor pauses, the filling valve opens, and the logic runs just as programmed. It's satisfying to watch everything run so smoothly, especially when all components are synced through RS links and communicating perfectly between Studio 5000 and FactoryTalk. Back on the HMI, there's a real-time bottle counter on the main screen. I've labeled it clearly so the operator knows how many bottles have been processed. The system also features a system status indicator that blinks when the system is running and stops when it's halted. These little UI elements help bring the SCADA to life. One thing I'm especially proud of is how I've implemented the emergency reset logic. When you hit the emergency button, it doesn't just stop the system, it locks it out. You can't start again until the reset button is pressed, and this button only becomes visible after the emergency condition is cleared. It's a small detail, but it adds a real-world safety touch to the system. To summarize, this project combines PLC logic, SCADA design, real-time monitoring, alarm handling, HMI navigation, and a realistic Factory.io simulation to create a full industrial automation environment. Everything is built from scratch, From designing the HMI layouts, writing ladder logic in Studio 5000, setting up alarms and trends in FactoryTalk View, and configuring every tag to sync with Factory I/O for seamless simulation. And that's a wrap. I hope you found this full walkthrough helpful and inspiring. If you're working on your own automation projects, I highly encourage you to try connecting Factory I/O with Studio 5000 and FactoryTalk View. Once you get the hang of it, the possibilities are endless. Don't forget to subscribe to Easy Electra for more full project breakdowns like this. And if you enjoyed the video, give it a thumbs up and share it with your engineering buddy. Thanks a lot for sticking around, and I'll see you in the next one. Until then, keep creating, keep automating, and keep leveling up. Peace out.